This is the final part of the program development walkthrough, and we're going to prepare our test trig program for loading onto the real machine. This is done by creating your machine code on the media you want to use for loading. There's a choice of 3: paper tape, mag tape or disk. There's no backdoor to loading the real machine, just like real life. The only alternative is to load it manually using the switches. But first, here's the catch. You have to write a loader program or bootstrap to get your program in. Again, there's no backdoor, so even this has to be loaded via the switches. The good news with the PleX emulation is that once the loader is in memory, assuming you've put it into the fixed store region, you won't ever have to do it again. Now you can choose to make your loader read from any device, or even make it read the switches first so the operator can choose a device at runtime. There are extra codes to read most of the switches on the machine, so you can use these for control at runtime if you like. The choice is completely up to you. You're the chief system programmer. Now, if the loader is too large for the fixed store, you could write a cut-down version and get this to load a secondary loader program which has all the extra functionality you need. Now, in case you ask, I'm reluctant to publish any system code, such as loaders, as it defeats the purpose of what PlasMa is all about. If you just use other people's programs or other unrealistic backdoors, I'm thinking of Wi-Fi links, Bluetooth, internet and so on, none of which were around back then, you miss out on a lot of the personal challenges and fun of those early days. Having no plan B to fall back on is a great motivator, and it's a great sense of achievement when you do get it working. Now, if you do get really stuck though, send me what you've written and I'll steer you in the right direction. Now don't forget, it's not a showstopper. You would only have to enter the excess words using the switches after power on, and this might be a workable compromise until you've cracked it. Okay, you've written your loader and entered it. Now what? Well, the assembler has options for creating files in any of the 3 media formats. Their file names have different extensions depending on the format, and these can be displayed with the Help Usage option. There's -8 for paper tape with 8-bit no parity, and that gives a .pl8 file. There's -7 for a paper tape with 7-bit plus parity, which gives a .pl7 file, and similarly for the other two, -G for tapes and -D for disks, giving you .pmt and .ped files respectively. Now, if your loader program expects 8-bit paper tape, you need to assemble the trig.pls test file like this: plasm-8 trig, or /plasm-8 trig. If your loader expects a mag tape, enter plasm-g trig. You could do both at the same time if you said -G8, say. Once you've created the media file, it has to be copied to an SD card, which is then the physical media for the chosen peripheral. You can view these media files if you are interested in seeing your machine code in the different formats. Paper tape files are easy as they are plain text. A simple text editor will show the punched holes. Mag tape and disk files are binary, so you'll typically need a hex viewer or hex editor to see their contents. The examples of these were shown in a previous video. And my loader expects an 8-bit paper tape, so I'll be using the .pl8 file. So how does this get onto the SD card? Well, the first thing to note, you do not use conventional methods, such as formatting the card and then copying the file with drag and drop or copy-paste. PlasMa does not recognize any file system, so the cards do not need formatting and must be written in raw sector mode, so you'll need a special utility. This is fairly easy on Linux and I believe Mac OS, as they should have built-in utilities called DD, which does exactly what we want. The only snag is it's a potentially dangerous tool, as you could easily overwrite your hard disk if you use it incorrectly. It has to be run as root to prevent accidental damage. There are many parameters to DD, but we only need 3. The input, which is your machine code file, in this case the .pl8 file. The output, which is your SD card device name, and finally a sync option to ensure any cached data is physically written to the device before the process ends. The device name depends on your computer configuration, but can be found by entering lsblk at the command prompt after inserting your SD card. If your computer does not have a dedicated SD card slot, you can use a USB slot with a suitable adapter. I've had success with a micro SD card USB adapter, which came bundled with some SD cards I bought. This will have a different device name to the SD card slot. Now you must be absolutely certain you identify the correct output device, otherwise you may corrupt your computer irreparably. The size value is a good guide. Now I cannot accept any responsibility for this, but I would strongly recommend you wrap the dd command into a script for safety, with your output device hard-coded into it. Contact me if you need any help with this. Now before moving on to the MS Windows method, I'll just mention how to do the reverse and copy an SD card back to your computer. As you'd expect, the input parameter should now be the SD card device name, and the output should be a file name which will be created or overwritten with the data. But in this case you also need to specify how much data to transfer. The default would be the complete SD card, which may be much more than you need. So you can use another parameter called count to specify the number of blocks to transfer. The block size used by PlasMa is 512 bytes, and this is the default used by DD. You can override it with a block size option, but there should be no need. Now it's up to you to guesstimate how many blocks to transfer. You can get an idea from the numbers displayed when you copy files to the SD card. I think DD calls these records. Right, now for MS Windows. Now I haven't found a simple equivalent to DD on MS Windows, but there is a freeware hex editor utility called HXD which does the job, albeit in a more convoluted way. The program is a conventional Windows program which looks like this. And as with other Windows programs, there are icons and keyboard shortcuts to make the following process simpler, but I'll show the menus method for clarity. Click Tools, Open Disk, and select your SD card device from the list. Untick the box Open as Read-Only and click OK. As with DD, it's crucial you pick the right device. The size and description should help. You'll see a warning to remind you of the danger. You should then see the current contents of your SD card in hex and ASCII. And it helps if you're reusing a PlasMa card, as you'll recognise the previous media contents. For example, old paper tape cards will be full of holes. Magtape cards will have M as the third byte, and exchangeable disk cards will have E as the third byte. So this helps to confirm you've opened the correct device. Next, click File Open. Select the .pl8 file. Check the box Open as Read-Only and click Open. The contents of the file will appear in a separate tabbed window. You then need to copy the contents from this tab to the other as follows. Click Edit, select All, and the contents will appear highlighted. Click File, Copy. Then click the tab for the removable disk. Click Edit, Paste, Write. The new contents will be coloured red. And click File, Save to write these changes back to the SD card. You'll get one more warning, which is your last chance, and then the card is ready to plug into the relevant peripheral slot on PlasMa. And as with the Linux method, copying data in the reverse direction from a card to your computer is the same process in reverse. You swap the read-only options and copy-paste in the opposite direction. Okay, we can now insert the card. And I'm assuming you've gone through the startup sequence and microcode 3 is loaded. If your loader starts at memory address 0, like mine, then just press reset and run. If not, set PC to the loader start address first. This loader is now waiting for the peripheral to become online, so press the relevant load switch, in this case PTR. The tape contents are copied into memory starting at address hex 10, which must match the start address specified in the source code. Now, your loader could use any address you like, as long as the source code matches. Now, this loader automatically continues to run code from address hex 10 after the program is loaded, but you can write yours to stop or loop, waiting for further operator instructions via the switches, keypad or any other peripheral. If all goes well, you should see the startup instructions for the trig program on the hopper. You can replicate what we did on the simulator if you like. Press stop and confirm PC is in the keypad wait loop. You can single step around the loop. Then press run to continue. You can now press keypad buttons A or B and see the display. Finally, I'll just revisit that flush keypad operation mentioned in the first video. And currently, if I press a button while it's plotting, you'll see that the button is ignored and the program always waits here for instructions, as intended. Now let's patch out the flush operation and see what happens. The listing file shows it's at addresses 1A and 1B, so I'll change these to no operation opcodes, or NOPs. The machine code for this is 0001, easy to remember, the other useful opcode being HALT, which is 0. We can either patch the memory via the instruction register, IR, by setting PC first, or patch the memory directly by setting the memory switches. There's not much difference if you're just changing a couple of words. If you're changing a lot, it's much easier to use the PC method with the load and ink switch, but I'll just use the memory switches here. So set 001A on the memory switches and confirm the old contents are 009E. Move the load target register to the memory contents, MC. Set 0001, the NOP instruction, on the load switches and press load. Alright, now for the next word. Set 001B on the memory switches. Confirm the old contents are 1100 and press load again. Right, the patch is done. Press run to resume. Right, now I'll press button A and then press button B while it's plotting. You can see it continues to plot the second wave without waiting. Right, that completes the end-to-end walkthrough. I hope that was useful. Any questions or problems, just shout. Thanks for watching.